Hello, alright, so we have the layout sketch plus drive of the angled elevator that we had, and basically what this was the one stage angled elevator with a wrist, and then we decided to have this drivetrain. There were some issues potentially of interference, especially right here, that I do want to consider, but overall, this is the architecture that we have. Uh, I guess just to start off, there were some issues with like this tube is interfering, right? So let's figure out if we can raise this up and then raise this a little bit. Unfortunately, I did not do it in the most parametric of ways, so I'll have to figure this out together. Looks like it works. I can just 4.5. Yeah, something like that. All right. What I think I'll be doing to represent a design process a little bit better is we're going to just start on designing this, and then as we encounter issues and things that like we may have not noticed, we'll like modify the CAD as is as we continue going through it. And that is generally how we're going to be running. That's generally how you'll run a design process, I guess, in FRC, right? So we have our layout sketch plus drive, and now the next thing we want to do is start creating some more documents. So we'll start off is it will probably have our layout sketch, right? So we have our layout sketch plus drive, and then we're gonna have to get our angled our probably what's next is probably our elevator. And then we can have like I think it's like elevator plus like the arm thing. And then maybe you'll do like the wrist plus, though it might be easier to connect it. Wrist plus intake, I think. It's something like this. This is probably what we'll end up having, but we'll probably figure out how we want to split it later as we start going through it. So we can probably just start with this elevator. So initially the reason why we went with the garage parts, right, is uh basically we wanted to, oh shoot. Actually, that reminds me. We need to do the version system. So after we make our layout sketch, we actually need to version things because because that allows us to transfer into the various drive documents. So the reason why we do this and the reason why we have separate documents in the first place is that allows us to version our like master sketch, and that allows us to make sure that when we update our master sketch, we don't have to worry about everything else. Actually, I actually don't want to do that. Uh, we don't have to worry about, say, I modified the layout sketch and I didn't realize this issue would happen. It doesn't update right away, so you can push the changes away from the layout sketch, and then you can also push updates to the main assembly as well. So what we can do now is we can probably just import all our tubes, and I don't know if I want to do the belly pan, honestly. That sounds annoying. So I'll probably just do these sketches, and then if I feel like it's necessary, I'll add the belly pan as well. But as is, this is probably enough. Like, I could add the battery too. Let's see. Yeah, that looks good enough. We don't really need any of the other sketches, so we're just kind of deriving this. And the reason why we're deriving this is we want to make sure that all the, I guess, like, everything that may interact with the elevator does exist. And this is important because we're going to be attaching, like, stuff to our elevator, right? And since we're attaching stuff to our elevator, since the elevator is going to be attached to the drivetrain, you're going to have to, well, know that it exists and not like account for it later into your assembly, where it can be kind of a pain. So after this, we're gonna be using the composite part tool here. How I'm doing this lookup is I'm using the Alt plus C command, and that allows me to basically very quickly just kind of add things, look things up, and that's really convenient when I don't have to. I don't want to like go up and I don't actually know the keybind, or like the keybind doesn't exist either or. But yeah, so here let's edit the appearance. I we can do like a, I don't know, like a default color like this, and that usually is good enough. So now we have this like bright blue, and this basically with the composite part here, composite part. When we do look at our insert, right, it only shows the composite part. Actually, what the frick? Is it not closed? It is closed. Huh? Okay. Oh, I guess that's the only one that exists. Okay, never mind. Don't worry about it. I'll show you a little bit later. So, next thing is we can probably get our tube next, right? So, it's like an angled tube, so I might approach this by like, what we can do is we can probably make a plane that is offset of, let me think about it. Line angle, maybe? Like this? I'm not sure. Okay, yeah, that looks right. Yeah. So we'll do something like this. And then we can figure out the points. So honestly, I really dislike working on stuff like this because what ends up happening is it's like, I don't know, you can't like face it correctly. Like you can't face it so it's like perfectly flat for your sketch. Actually, I could probably ask someone about this and I could probably get an answer and that would probably be useful for you as well. Uh but as is, I'll have to be working in this incredibly scuffed way. Okay. So what I'm doing is I'm just making this I'm just making the 2x2 here. And then I'm going to be making, actually, let me think about it. I think it depends on the intake size actually, which is gonna be funky actually. But I'm curious. I have not like seen this architecture before, so there might be a reason why people don't use it, and I don't know why, but we'll figure this out really quickly on why people don't use this architecture because I'm not sure myself. But we can do something like this. And then we'll mirror it. The one thing that's annoying about this is the fact that the carriage is really big. And that makes the elevator a little bit wonky. So I'm not a fan of that actually. But we'll figure it out. Now that we have the elevator, we can make the carriage. And then once we have a carriage, we can start modeling like the The arm thing? Is that what it's called? I don't know what it's called. I don't actually know the terminology for the angled elevator, unfortunately. Alright, let's think about this. So we'll need... So that'll be... Okay, I wonder if we can just like... That's good enough. I apologize for your eyes. Something like this. One by one. And then use this as a center mirror line. And then mirror this. No. Okay. Mirror this. So and that should allow for a carriage. So I just used the mirror tool here, and that allowed us to get some amount of carriage size. And I don't remember actually what the bearing size is, like the gap for the overlap. So we'll quickly figure that out by probably just cutting it out, because I am a bit lazy about this, but I think that's generally all I need. So we can probably start with just yeah, we can probably start with extruding everything here. So let's just do that. Yeah. And we extrude everything. That's crazy. And after this, okay, moving on. Pretend nothing happened. Apologize for the random cut in the video if I ended up doing that. But we're gonna quickly run a quick tube converter here, and we'll run a quick tube converter here, and then we can quickly figure, and that will allow us to get all our tubes. And I'll make this also 1/16 because I feel like I don't know. It's probably fine to make it 1/16 here. No need to make it overkill. The reason for this like gap right here is I wanted to add foam to the like between the elevator stage and the wheel again. Like the stage, the carriage plus this bottom portion, just to make sure that the aluminum doesn't like instantly die. And like if I actually was doing this for real, I might make this like, I wonder if there's a way to set this as 1/8. Yeah, that does the okay. But yeah, that's 1/8. That'll exist. Okay, apparently the West Coast Products elevator blocks do not exist in Onshape. I forgot about this. I'm gonna check one more time, but they probably don't exist. So we'll quickly look that up and get that. Okay, I lied. I realized that I could just get it from the 235 Eclipse library, so we'll do that later. I guess the next step here is we have like some elevator theme bob. We'll get it to plug here, and we can run the 0.25 bulk config. I'll quickly to plug right here. Apologies for the pauses and stuff. I am doing this. I've done zero prep for this, so I am trying to figure this out as we go. So this is probably realistic to what I might do in like a season. Including me being done with the keybinds and whatnot. Actually, we'd be transforming here. Okay, so we transform here. We will transform to the tube, and then what we're looking to do is we want to add like a 1/4 inch plate or something. Actually, no. I would make the center, but I realize it's angled, so it'd be kind of weird. Oh, it's chamfered too. That's actually a pain. But we can do it. We can use this hole. Okay. Yeah. So we have this. This now exists, and then we can make our plate. So typically, a lot of people would use the Gusset feature script, but I find that the Gusset feature script is kind of annoying, and like you can just make it by hand if you wanted to. And the load times are usually a lot better doing it by hand, so I'll just do it by hand here. That probably looks good to me. So what we do is we basically get all the all the holes that you want, and then you add center arcs. Yeah, you add center arcs, and then you kind of just connect them all together using the tangent constraint. And then once you do that, it kind of just goes together. So we'll do something like this, like this, like that. I don't know. I don't like it. Well, I'll make it like good, like actually good, in a second. Ooh. Do 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 do. Break. 1 second. Okay, so ah, I'm gonna make this tangent. Yeah, that looks pretty. And then can I do this now? It is now legal for me to do that. And then let's just constrain this plate like this. It's nice and pretty now. I don't actually know how like physics works, so the theory behind it is it's fine, but I'm going to do this anyway, where I'll add a bunch of unnecessary material to make this a triangle, and hopefully that extra material is somewhat useful. But if I don't like this and I get like design reviewed later and it happens to not be good practice or whatever, then don't do it. But this probably looks pretty. Yeah, and we'll also disable imprinting here. This is a thing. This is a type of thing where you'd most definitely pocket it if you were to actually do it in real life. But the nice thing about how we're running the setup, especially, is since we're running an angled elevator, right? And this is pretty reasonably low to the ground. We can just get away of making it 1/4 inch. And yeah, it weighs like 3 pounds, but it also acts as flip, that is a little too thick. Uh Actually it weighs like 0.75. But it's low enough to the ground, and that'll be pretty convenient because I mean yeah, ballast weight down, very good. So we got that. The next step will probably be, I guess, making technically it's the gearbox plus the whole like chain setup. So what we can do to figure this out is we can use I we would use the linear like mechanism calculator on Recalc here to figure this out. But I actually have no clue. But uh, what we'll be looking for yet, because nothing is actually modeled. But we can start working on it. So the travel distance is 50 inches. Uh, and we'll just assume like 80% efficiency or something. Two neos, spool diameter. West Coast product sprockets. I'm not gonna lie, I have no clue. I'm going to. I think I'm just gonna send it with a 22, I think, and that'll work. I haven't like. Okay. I'm not actually sure. I'm going through the catalog right now and I'm trying to figure out how I want to run the setup, because what we're gonna have to do is we're gonna have gearbox on the bottom, right? And then we'll have like some sort of a sprocket here, right? That goes to a sprocket up here. And then from the sprocket up here. Oh shoot. Actually, I'll have to fix the master sketch then. You go to a sprocket up here, and then from the sprocket up here, you have a chain that goes up and down. And then from the chain that goes up and down, you have something that hooks the chain, right? And the question that I have is, if I do create chain, right? If I do make chain, how do I attach the chain so that it's like nice? So that's 51. Let's try chain calcing this. And we want to use realistic as well. And let's say that we're using 24. Yeah, let's try that. And then we can run it in place. But we're quickly just... Yeah. So as we see here, there is a slight issue in which the issue... Yeah, that's not great. Hmm. Let me look. Does West Coast Products sell anything that I potentially would want? Cascade pulley, timing belt, clamping bearing blocks. I could try 3D printing it. Another jank solution you can do is you can run like a... I could run a nut strip here, and then have a plate on the nut strip, and then attach it to that plate that's on the nut strip. That could work. I'm not a fan of it, but it could. I'm actually a little concerned that the 25 chain isn't strong enough, though. 25 chain. So we'll figure that out. But 35 chain is also really heavy, so that's the one issue. So we'll take a look. I mean, the largest size that we have of the hex hub is 15 tooth. Let's just do 25 chain. If someone gets angry at me for it later, so be it. Yeah. But then what we need to figure out is... Actually, could I do that? Let me do something. Let me look up Rev Robotics. Rev Gearbox. Two motor through bore. There's the Rev 2 motor through bore, right? Can I just use that? Like this thing right here. Like if I didn't want to make a gearbox. Why does this CAD look... Yeah, it is a 2-inch pitch, so... One, two... It's like an ultra... It's like And then I can change the ratio too. But the distance between that is 2 inches. So what I could do... Since that is already 1/8. Yeah, let's do that. That'll make life easier for me. And because I am lazy, that is how we'll be running it. So we'll run 0.6 here. Something like this. And then we can extrude, remove 2. Like that. Yeah, that works. That's crazy. And then we'll add we'll make our own like version of a bearing block here. Could you bearing hat the bearing block after you... I haven't done that before. Like, do a bearing hat where the bearing block is. Actually, this is already 2 inches, right? And then by doing that, in theory, you can have a bearing block with the bearing like retention preset in. That might be cool. I'll try layering it and see how it goes. So it might be a pain in the butt to remove the bearing though. Yeah, something like this. Bearing block now exists. That feels very big. And now that feels uncomfortably small. Man, it's probably fine. I'll make it 1/4 inch. Do. Do, do, do. Yeah, something like that. Then after that, we can get our bearing here. We can put a through-board gearbox that goes all the way through. And I'll do something a little bit deranged. To save on a transform, I'll just import the gearbox, not the gearbox, the under hex bearing here, and then transform it. Did I do it? Hello? I'm clicking. Okay, there it is. I'm also incredibly... Alright. Now that is a thing. I actually just want to know. Can I do this? It is completely useless. Can I do this? I can do this. Does this do anything? I don't know. It might. Uh, but I won't think very hard about it, so who knows? Oh, that's crazy. Rev sells it. So what we're doing here is we're just transforming, we're slowly building it all up. And you might be wondering why I chose not to do a nice custom gearbox and like all that fancy stuff. And that's just because, generally speaking, especially for your first one, we kind of want to just get a feel for we kind of want to just get a feel of like how like we want to do again, how like the robot design process works, right? And a lot of the time you don't really need like all the fancy like stuff. Did I? Oh, did the bearing hat disappear? Where's the bearing hat? Oh, it's in Narnia. Why is the bearing hat there? Oh, okay. There you go. And then fixing some of the transforms that I was doing. What we quickly realize is this is out of frame perimeter by like a very tiny amount. So we'll probably have to fix that. But I don't want to fix it yet because I don't know how much I need to fix it by. So what we'll do is we'll make the chain first. And then once we know that the chain exists, we can figure out how much we want to fix it by. And I mean, yeah. Let's This is where you just kind of guess and check until it works. There's probably a better way of doing it. Like if I get like a mate connector in the middle of the sprocket, it probably will make it. It'll probably be faster if I made it that way. But I also don't want to think. So this it is. This shall be the solution. I guess since we're doing that now, one second. We should probably modify our master sketch and see how we can fix this. So you can see here, we need like another like 0.5 inches to make this work, right? So that is not the folder. Note, this is not all of my robots. This is just my first robot and some meme bot. Don't think about it very hard. But this, we have this here. We can go back to our master sketch and we can quickly figure out how we want to adjust this. And how I want to do it here is because I want to keep this number pretty like whole and even, right? I'll probably do that. And then another thing I'll be doing while we're at it is like making this like 16 inches or something like that. And that'll make it easier because we'll get more clearance space for the 3-board gearbox as well. And then we'll version this like that. Oh shoot, I only have 15 minutes. Alright, now that that is done, we can go back to arm plus elevator plus arm thing or whatever it's called. And then update this derived instance here. And what that will allow us to do is that in theory, cross fingers, it should just update automatically. Assuming I did not troll. Rage. Okay. So while we're at it, what we have right now is we have our elevator, we have the tubes, we have the chain. We do need to figure out a way to connect this. So we'll probably end up doing is like some sort of nut strip setup, right? That clamps onto this, so then we have like bolts that are going through. And then we have below. I love unshaped load times. Let's go. Okay, we're done. Okay. You see, we fixed it. We moved it down. It now all works. And it looks like nothing else is broken, so we're still doing okay. Yeah. I guess what's next is we can, let's think. Okay, that's probably going to be an issue. I don't like how low that is. Do I need it to be that low? Because right now, how we're running it is actually interfering with the swerve module. So I can't get it full width. And that's not great. Actually, no, we're fine. Okay, I'll probably make the how can we do this? I'll probably make the what's next? I'll probably do the arm thing here. Or not the arm thing, whatever this like tube thing is. We'll bring that out and then we'll CAD that. Then we'll figure out the gearbox down here with the shaft going out, I think. And then once we do that, I think we're set for the elevator. Yeah. So do I have to transform this? I wonder if I can just that's crazy. I'll add it to the composite part too. That way we don't have to bother with it. Actually, that is not a composite part. What am I talking about? I'll just keep as new. And then we can do our shaft generator here. Bolt and washer. And then we can do up to face. And in about this stage of the like design process, you kind of start just jumping around and doing what's kind of fun. Because it's not like you need to like do it in a very like specific order. It's kind of like, oh yeah, I want to do this because it's more convenient type thing. And then I do this next thing because it seems nice and convenient. And then we rinse and repeat until the robot seems like it's slowly like coming together. And that is probably the best way I can explain how you run this whole like design process. Which unfortunately is not the most, I guess, the easiest to introduce for most people, especially because it's not like just like a clear set of instructions. We're just like kind of going through the process, right? So like I'm like designing some stuff and we're kind of figuring this out. And it's not like we have like a clear solution to how we want to be approaching this. It just happens to be the way that it is, and the way that we do it may or may not be the most like ideal way of doing it, but like it's a way and we learn from it, and once we learn we can figure out a new more ideal version later and then rinse and repeat, right? So it's like hmm, like here what I'm learning is the sprocket here might have an interference issue with this, which is going to be actually a giant pain in the butt now I think of it. Let's see. Can I do that? I can get just only rev sprockets. 32. Actually, there's a workaround for this. And actually, I don't like the workaround either because That makes the intake like really small. And I want to keep this full over the bumper intake. So since I don't know a solution to that right now, I'm going to procrastinate on it and I will do something else. So I did just say that I don't like using the Gusset feature script, but it's probably good that I show you how to use it. So what we do is we take the we get the Gusset feature script. I select the holes like this. Do 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 do. I now remember. I now understand the issue. The reason why I do not have a 16-inch tube, and that is because that lever is actually insane. Holy frick! And also, I might be able to get away with just keeping the tube at like 20 inches. Yeah. Yeah, I don't like this. Alright, this is where I'm gonna start ignoring the master sketch and not do what the master sketch says for the reason of I don't need to. But what I can do here is because the mechanics of the master sketch are how it works is it uses just this hole and we're just using that parametrically up and down, right? We already know that if we move this tube like 2 inches up here, it goes up 2 inches here, but it'll never really interfere unless I do something like really stupid. So let's just move it up here. Yeah. Let's see. On a side note, apparently Onshape, according to the Onshape website, it is built for agile project design, product design, whatever that is. Wait, does it mean like agile project management, or does it mean just like agile in it like being fast? Because I'm kind of curious now. Because if it's like agile for product development, that'd be interesting. And this is where Onshape decides to love me with its incredible 2 FPS load times. And yes, there's probably a more parametric way of doing this. I'm just typing in random numbers. Uh, Actually, we can kind of like look and figure out how we want to place this. So general like rule of thumb is you want to avoid, especially for I guess it's not a rule of thumb, but it's like you don't really need to like make tubes flush if you don't need them to be. So just don't. Uh what can I do? What's the most This is actually an awful way of doing it. I shall do it anyway. And while we talk, we're getting this tube. We're gonna probably attach it to like a large gusset or something here, and then I'll probably do another large gusset going down. And it doesn't really matter, right? Because like the whole like mechanism is up here. So the theory is that everything works. Hmm. Oh, I forgot to add music to this video. That is unlucky. Oh well, you can probably just use your own music while we're at it, right? Uh, yeah. Onshape's being weird. I'm gonna refresh it, but I have to go. This is like part like 2.5 or something like that, and hopefully this is useful. I'm gonna like continue. I'll like make another video really shortly after I like go to my meeting, and we can probably figure out whatever we're doing here. But yeah, that is 1 hour of or 15 minutes of elevator, I guess. But yeah.